Okay, so now let's do question 4. It says 2 kg block is at rest on a smooth frictionless horizontal table. The length of the block is x. So here you have a block which the distance from here to there is x. That's the length of the block. Okay, so it says a bullet of mass 0.015 kg traveling east at strikes the block and passes straight through it with constant acceleration. Refer to the diagram below. Ignore any loss of mass of the bullet and the block. Okay, so it says state the principle of conservation of linear momentum, and we know that that's easy, everyone knows that. Okay, so and in my videos there's where I stated the conservation of linear momentum. If you haven't watched them, please go and watch them. That in an isolated system the total linear momentum is conserved, so meaning that in terms of equation the total momentum initial is equal to the sum of momentum final in isolated system. You can just check my videos where I will teach you about this one. The block moves east at this after the bullet has emerged from it. So 4.2 says calculate the magnitude of the velocity of the bullet immediately after it emerges from the block. Okay, so here we have to consider this as a system before, so it can be system initial and then this is a system after. So initial, how many objects we have? We have 2 objects. We have a block and we have a bullet. So according to this equation here, we're going to say the mass of the bullet multiplied by the velocity initial of the bullet. Since the block was initially at rest, this block here was at rest initially, and then we are going to say mass of that block. I'm going to use capital letter B for that, multiplied by its velocity, and velocity initial is 0, so that will turn everything to be 0. So it's better to write 0 here or not waste time. So is equal to final, we have a velocity of the bullet, v final of the bullet, plus velocity of mass of the block multiplied by velocity final of the block. Okay, so the choice of direction I prefer to take east as positive. Take east as positive. So anything that's going east is going to be positive. Okay, so here let's check this one. Mass of B, v initial of B. So mass of the bullet is 0.015 multiplied by its velocity initial. Its velocity initial is 400 is equal to here the mass of the bullet finally. You see, so now we want to calculate this velocity final of the bullet. So but we have a mass of the bullet which is still 0.015 multiplied by its velocity. Let's just write VF plus this one here. So for this one it's gonna be, I will write it here, it's going to be mass of the block, which block is 2 kg multiplied by its velocity, which is 0.7. so since it's going to the east, it's going to be positive. Okay, so here if we can take, you see that this, it's on this side here, it was supposed to be here. So if we can take this, we jump it to this side, so it's gonna be positive, it's gonna be negative, right? So if I rewrite that, it's going to be let me use a different color. It's going to be 0.15 multiplied by 400. Let's bring our calculator. 0.15 multiplied by 400 is 6. So you have 6 in this side, you are going to have 6, and then this is 2 times 0.7. Let's bring our calculator again. 2 times 0.7, so it's 1.4. Okay, so we bring this to the other side. So if you bring it to the other side, it's going to have a negative sign, so it's going to be negative 1.4 is equal to, this side you are left with 0.015 multiplied by f final. Remember, as I said, you take this to the other side, so it becomes negative. Okay, so we're going to say 6.6 minus 1.4 divided by 0.15. So our v final is equal to 6 minus 1.4 divided by 0.015. It is the velocity final of the bullet. But let's punch our calculator. Okay, so we have 6 minus 1.4, which is this. Then we divide this by 0.015. Okay, so it's 306.67. okay, so that's a velocity final. So your velocity final, it's gonna be your velocity final is going to be 306.67 meter per second squared. Okay, so it's going to the east again. So last one, let's do 4.3. It says if the bullet takes 0.02 to travel through the block, calculate the length x of the block. So now I'm just going to copy this to the other side so I can do it clear. Okay, so I copy this. Okay, so we're doing 4.3. So 4.3, which says if the bullet takes 0. So the change in time is equal to 0.002 seconds. So as I said in my videos for momentum in terms of Newton's second law, we said that F net is equal to the change in momentum of the object divided by the change in time. So remember that here we want to calculate the distance. We want to calculate the distance x. So we have change in time. So we have a change in time, we have change in momentum. So what we can do, we can just calculate the F net. So why I'm saying we can calculate the F net, because remember we have this. We have something like this. We have this. F net is equal to ma. So if you have acceleration and you have this formula again, you have a change in x is equal to, let me just use the simple one. Let me just give you this one. We have a v final squared is equal to v initial squared plus 2a x change in time. Okay, so this is the formula that you must use when you're asked to find the change, or not change in time here, it was supposed to be change in x. When you're supposed to find the change in x, which is a displacement. But we have a problem here. Our problem is like we don't have acceleration, so we have to come with a way that we can find the acceleration of the object. We have a v final, which is what we just calculated earlier, is 306.67. We have a v initial, which is what we are given. So v initial is this one, so it was given as 400 here. Okay, so what we want to calculate is the acceleration, and this is the only thing that we can use here in order to get acceleration, because it says that the F net is equal to change in momentum of the object divided by the change in time of the object. So we have a force that's exerted on the bullet from here up to this position. So if you have a force of that, then we can calculate the acceleration from here up to there, because they said that the acceleration is constant, so also the force was constant. Okay, so without wasting time, let's just do this one here. Let's just do this. Okay, so we're going to say F net is equal to change in momentum, which is just a mass of the object, 0.015, and you take what was the velocity final. Remember that the change in momentum p is given by the mass, open bracket, v final minus v initial. So what was the v final was 306.67 306.67. Let me go and confirm that. It's 306.67. Okay, so here it is, yeah, 306.67. Then okay, so we don't close the bracket, we subtract it by 400, and then this we divide it by 0.002. so our F net is going to be let's bring up our calculator, and then let me take it to here. Okay, so we have 0.015, then open bracket, we have a 306.67, we minus 400, then you get your answer here, then you divide this by 0.002. okay, so we get minus 699.975. this is what we get, Newton. So the negative sign tells you that that force is pointing to the right, because we said that anything that's going to the left is going to be positive east. This is east, right? So this tells you that this is pointing this direction, is pointing west, the F net. So we can just say F net is equal to 699.975 Newton west. So it's pointing west. Remember that this is a vector. And then to calculate the acceleration, then we have to say F net is equal to ma, and we know what's F net. 699.975 is equal to accelerate mass, we have it is 0.015 multiplied by acceleration. So acceleration is going to be this, which is 699.975 you divided by 0.015. so that's going to be your acceleration. So let's do it. Bring our calculator. So it's 699.975 we divided by 0.015. so you get 46,665 meter per second squared. And remember that since this was negative, also this is going to go to west, because acceleration points in the same direction as a F resultant. Okay, so now we have to go ahead and substitute there and find the displacement. So let's do that. I will need to wrap this because I don't have a space. Okay, so if we substitute here, we're going to have V final squared is equal to V initial squared plus 2AX multiplied by the change in X. So V final squared, V final, which was 306.67 squared, minus V initial was 400 squared, is equal to 2A as 4665 multiplied by the change in X. You see, so we're just going to write, bring up our calculator. another 6 here. Let's bring up our calculator and calculate it. Okay, so we have the square root of 306.67 squared is this minus 400 square root. So here I will get minus 65,900 153.51, which is equal to this one here. When you multiply that by 2, you're going to get you multiply this by 2, which is going to be this one here, and then you're going to get 2 open bracket 46,665. okay, you get 93,330 change in x, and then now you have to find the change in x. So change in x, it's given by, remember that this acceleration was supposed to be negative, so this one here is going to get a negative sign, right? Because acceleration was supposed to be negative, it's going to west, so anything that's going to west, it gets a negative sign. So we just going to, let me zoom out this. Okay, so the change in x